one I will use is now C11. Put it that way. And that's just because of the atomics, pretty much. That's it.
Maybe we can break down a little bit, like what happens in the newer ones, like what the older ones improved, so that we kind of get the wrap.
So the C89 or C90, depending on how you want to, which organization you want to standardize on, that's the most like portable version you can get there. But that's the first standardization, like the ANSI, ISO, whatever you call it. Then you've got the C. It's technically a mini one in between. There's the C95, which is what Visual Studio supported for a very, very long time. Then there's, but that one, no one really knows about that one. The C99, which is the first big one. C99 introduced things like, single line comments. You can now declare variables anywhere rather than just at the top of the scope. What else did C99 bring in? A few other things. I can't remember at this moment. And VLAs, which no one ever likes or uses because they're awful. But then it came to C11. C11 was kind of copying the C++11 atomics model. So they added a way of doing generic, like a generalized form of atomics and threading and synchronization primitives and such. So that's what C11 kind of solved. Then there's the newer version C17, which was kind of revision on C11, which also deprecated VLAs. Also C11 also added the generic thing, which I never use either. I find it actually kind of useless. There's not really a case for it. And then the C23, which I think is the latest one, which has added some new features like type of, or decal type, or whatever it's called, or it's now got a null pointer in there as well because reasons, and all these other different things. C23 because it's like
auto.
There's auto, yeah, auto. They replaced the meaning of auto to now mean type inference. This is why I'm saying C11's the last one for me at least.
Okay, Ryan.
So yeah, I mean, I think Bill and I will agree that the newer C standards, like they're kind of not being C anymore. Like I don't really have much in common with the people who seem to be working on the C standard at this point. Like it doesn't seem like it is preserving the value of C as I understand it. But I don't use C11 probably just because MSVC does now support it actually, so I could be using it, but for the longest time they didn't. Like I was on 2017 for a while, and then I think I might still be on 2019 on the computer I'm streaming this from.
I think I'm still on 2019 as well, actually. But
do they have C11?
Or am I 22? I've got both, I think.
Okay, yeah. I think
I can't remember which one it is.
I know it's like, I know technically before they got C11 support, it was like not even technically C99 because they didn't support like some like two features or something, so it wasn't technically C99 support, but it was like close enough. Like you could write your code. Yeah. You could write your code that could compile in MSVC or Clang, and it's like roughly C99.
And even then, C99 was only recently supported as well, because again, for the longest time they were using C95, I think that's the name of it, right, which was like a fake substandard that didn't really exist, but except in the Visual C compiler, where effectively it was still C89, but they had single line comments. Effectively.
Although you could do
very weird standard.
You could do declare anywhere since maybe 2015 is when you start doing declare anywhere.
I can't remember when it was, but I remember probably 2015. Yeah.
Okay.
It's just one of those. So yes, the question is which version, what I think is the correct one. My answer is, I don't know, C99 or C11 now at this point. Again, it's the newer versions. They're adding too much, all of these new stuff, and it's kind of getting away from the essence of C as well. They're wanting C to be a more modern language and do all these new features. And I'm like, great, you guys don't understand why people still use C. It's not because,
That's to me like a weird thing. Like C++ was meant to be this like crazy, all the features language in one language. Like, and for years it was like slapping of like all the stuff goes in there, like, like anything. And now when C gets these improvements, it's like, wow. I mean, why? Why is that? Do you know the people that are working in the committee? Like, why they?
Well, technically, we know one, but he's always answering no. He never votes. It's called Eskil Steenberg. He just says, he still uses C89 for goodness sake. Like, he's not even using any other version. He's just the very first one he's using. He's happy with it.
Honestly, I don't understand what Eskil is doing there on the committee. I need to ask him. We're going to have a podcast episode.
Okay, there are certain things he actually is standardizing to make them actually decent. Actually, there are certain things I think he's working on. It's just, he's not adding new features. He wants things to be defined correctly.
Okay. But it seemed like everybody in the C committee kind of should have this mentality, because like the language has this mentality, right? Like doesn't make sense. Like
so one of the things
they're a committee.
Ryan,
sorry.
It's your floor. Go.
I don't know if I might have a slight delay. Also, my internet's not great, but so the thing I wanted to say about the standards thing is, like, I think a lot of people they think of like the standards almost like the government of like the C universe. Like they're sort of like, oh, like the standards committee decides things and then everyone goes and implements it, and it's like that's how it works. And so if someone makes a decision in the standard, then it's like it just flows downwards from there. They're like this weird, like, I don't know, like unelected bureaucrat like circle up here, and they're doing like they make these decisions and then it flows downwards. But in my head, it's like it's actually really the reverse of that. Like I don't think, to me, what's important is who implements what, because again, like the important thing for me is the tool chain. And so if someone has a bunch of C compilers that do certain things, to me the standard is whatever they happen to be doing. And if the spec goes off and does ridiculous nonsense like they're doing, it's not really that material to me, because it's like on the ground, people have to compile C code tomorrow that was written 20 years ago, period. And they're not going to stop doing that. And so that is the standard to me. Like, that's the only standard I happen to care about.
Yeah.
And so whatever they keep doing is like, whatever, like the people who actually wrote the code and built the tools and actually did all that, that's where all the actual power is people who actually built stuff. So that's kind of how I feel about it. So, and that matches up with what Bill said as well. Like C11, C99, that's what people have actually done. That's where all the code is. That's what people have to build. And so, you know, that's kind of where is like stable ground in my head.
But you said something that I didn't really understand. You said that like the standard is de facto the toolchain people and whatever the toolchain is accepting. But toolchain people will implement the new features of the new standard, right?
Okay, I can probably make the essences. There's a difference between de facto and de jure, right?
Yeah.
Is it the written law or the essence of it?
Right.
And this is when some people, the spec is there, that is the written law, but that doesn't mean anyone adheres to it. Right? Just because it's written down doesn't mean anyone's going to be doing it. And in fact, most compilers do things very different to actually how the spec works. So yes, those compilers compared to the written law, the de jure, is wrong. But the real world is, these are the compilers, this is what I've got to deal with. And that also includes all of the extensions as well. Because no one, and I mean virtually no one, is actually writing pure C. We are all using loads of extensions implicitly across all the different compilers. So we actually find the overlapping of all the different extensions and use all them to make things work correctly. Because if you use pure C, you'll actually hit some really like annoying things that you won't be able to do. Like a lot of like people use like built-in intrinsics, or they'll use some minor, even pragma once, for goodness sake, some people use, which is like an extension, but it's on pretty much every compiler. So you have all of these different aspects, which are, we know what the actual like real world C is. We don't really care about the spec, except when we're trying to find bugs. If that makes any sense. Like here's how one compiler's implemented it. Or we look, if we want to reference the spec, that's when we want to implement a C compiler. And then we go, okay, we've implemented the spec. Now we extend it. That's kind of the purpose of a spec, in my opinion. It's not the law. It's I'm trying to figure out what's a better way. It's de jure, not de facto.
But it's still like if the C23 introduces the new auto keyword for type inference, at some point people working on the toolchain will add this to the compiler, right?
Yeah. No, you're not wrong. It's just the question is, you still need to look for that subset and overlap with all the compilers. Like I doubt Visual Studio is going to add C23 features anytime soon, especially since I kind of I'm not going to say anything, but from what I've heard in Microsoft, let's say the Visual Studio team is not doing much now. Yeah.
Okay. So you're saying that the time that will take to actually implement this across the compilers is going to be tremendous.
Yes.
Okay.
Well, it's not even necessarily that. It might not even happen for some compilers.
Okay.
there's uh there's C the C spec by design is abstract with respect to the target hardware, but everyone who actually writes C, they need to understand the target hardware. Like, you actually have to understand what the hardware is going to be doing. Nobody's writing to the abstract spec really, and like not caring about what the computer actually is doing at a lower level. But C, the whole pitch of C was like, oh, we're going to make this language where certain constructs can be portable inside of it. Obviously, not all of the code can be, because the code is so wound together with what the hardware is actually having to do. But some constructs can be standard, like, you know, if you have certain type definitions or certain very simple code, it'll translate fine. But that's the whole pitch of C, right? It's like, oh, we're going to make this spec abstract with respect to the actual underlying hardware platforms. And so, like, I'm just agreeing with Bill again. There's no, sorry. I'm sorry, but it's like nobody's writing C because they're writing C with MSVC on x64 on Windows. Like, that's the actual thing they're writing to. That's
but Ryan,
the actual
don't you know
spec,
they're invoking undefined behavior doing that? Don't you know it's all
right?
undefined behavior?
Yeah, exactly. Yeah.
And it's not like this is where you get some of the what is it? The compiler autists at lawyers, where they'll go and like say, well, the spec says this, so therefore you're invoking undefined behavior. And I'm like, yes, I might be invoking, but the thing is, it's defined like this in this compiler, and this compiler. And I know it consistently, it will be defined this way on those compilers. But so, no, that's undefined behavior according to the spec. And I'm like, okay.
Yeah. Yeah.
All right. Which C standard RAD debugger is using?
C99. We don't use any C11 stuff, so it's just C99, or some subset of it, whatever MSVC happens to compile.
Okay. All right. On to the next question. Now it's gonna be okay. I will swap the order of the question to make it
okay
more interesting, because you just said that like C new standards, dramatic, awful, don't do anything, and so I'm gonna ask the question, starting with Ryan. What features in C do you lack?
Do I lack? Yeah, I mean, it's kind of hard to say, because the things I lack, I don't necessarily want the compiler to be doing, if that makes sense. Like Bill brought up like metaprogramming stuff, and it's like, I don't really know if I want the C compiler to be providing me compile time execution or something. It's like, I can just write a program that runs, it's fine. Like, that shouldn't be an extension to the language or something. My opinion is like, I don't really want C for more features, exactly. Like, the whole reason why I'm building my code base on C is to build my own little code base around it. It's where I can build the features I need. So I'm trying to think of a feature where I'm like, oh, if only C had that. I mean, there are cases where I'm like, type of would make this a lot simpler, for example, or decal type, or whatever it happens to be called. Or like, oh, if the compiler automatically generated like some runtime type information tables, like that would make certain tasks simpler for me because someone else would have done the work. But it's hard to say, just because it's like, it's a matter of, do I want someone else behind a committee, behind some giant corporation maintaining like the MSVC compiler or whatever? Do I want them implementing this feature, or do I want to be implementing this feature? And usually the answer is like, I think I would rather just do it, because, you know what I mean? So,
but
I hate to avoid the question,
like,
but...
Exactly. Like, you would have this feature implemented as you wish, okay, as you desire. You can be the person who's gonna implement this feature. Like,
oh man,
you don't need to like abstract this into like, oh my god, if the people that I know are gonna work on this feature, then I don't want it. Like, is there technically a feature in C language from other languages that you would use if it was there?
Yeah, I mean, you know, there probably is. I'm having trouble thinking of it.
Do you want me to give you a hint? I'm not saying it's what I want, but I could give you a hint maybe for you.
Oh,
okay, yeah. That would help.
There we go.
Yeah.
Come on. What about like slices? Like literally a pointer plus a length.
Yeah, So
just the syntax for that.
It's one of those things where it's like you could find patterns that I tend to use a lot and replace them with a more succinct syntax. I don't know. I would probably accept that. Like, it wouldn't be that bad. It's just hard to know if that's like the highest priority. I don't know. Because it's like I'm just writing structs that are slices anyways in my case, so I don't know if I care like that much. I mean, the syntax would help a little bit, but it's yeah. I don't know. I'm sorry, I don't have a good answer. I feel like I'm sure I could find one if I thought about it for a long time, but there's nothing I'm like, oh, if only C had this one feature, because I can just kind of do what I need to mostly.
Like that's why I was trying to give hints. Maybe another one might be some other stuff from C++, like again, default arguments to procedures and such. Like oh, this is, instead if we don't type this one, it's got a default like true or a 1 2 3 or something like that. I'm just trying to give ideas. I'm not saying they're correct ideas.
I tend to just do that with like with a macro, like with a struct parameter that wraps like, so you've got a struct pointer parameter, and then behind a macro you can you pass the struct initializer, and then you use like va args or whatever. I mean, what's like one example? I feel like I don't have a good like concrete feature idea here, but like the variadic arguments situation seems like a mess. So that would be good to clean up, like, I guess. Again, not really a material feature I can give you.
You're either avoiding the question. You're either avoiding the question, or C is the perfect language. And
no, it's not the perfect language, because but it's perfect. It's imperfect because it has too much. Like, it tries to go too far, actually. Like, that's actually the problem. So it's not like if you added more features to C, you'd make it better. C actually needs to be rolled back. Like, it's actually trying to go too far. So it's not that C is perfect. It's just that more features wouldn't fix it, if that makes sense.
Yeah.
Removing features is what we're gonna get to. So, okay, hold your horses.
Okay.
Now, Bill.
Yes.
I've got an idea.
Oh, go. Ooh.
The build model is horrible. So you should just fix that. Like, go back to like the Turbo Pascal style builds, so where it's like, which I'm assuming is where Odin derived its like ideas for like modules and distribution. Just actually build a proper module system in C. That would probably fix a lot. Maybe.
Okay, we got one feature from Ryan. Nice. Nice. Now, Bill, if you, technically speaking, if you say any other feature than this, or not say this feature, you disagree with Ryan. Just want to let you know before.
Okay, there we go. Perfect, yes.
So it's just going to be the first time where you disagree with Ryan. Tell me, what features in C do you lack?
Do I lack? Right, so to get the story of how even Odin came about, this is explain what I was doing. So this was going back 9 years ago. The beginning, literally my New Year's resolution was to start every new project, hobby project I did in C, and see what I wanted from a language. And it turned out I didn't need very much. But after about 4 or 5 months, I was getting frustrated with C, because there were certain things where I'm like, look, I know from other languages this is really useful. And the first two things that I implemented were slices and defer, right? Wait, I'm going to get to it. This was at the time, right? And then eventually I was trying to fix other things. Like, I was realizing, all the C things are broken, like the implicit conversions are bad. Like, there's loads of things I actually kept trying to fix, and then realized at this point I should just make my own language, which is why Odin came about. Now, my views have changed on this over the years, actually.
I have another idea.
Yeah?
Sorry.
I'll explain. So my views have changed, but like, I've actually don't even want defer in C, because Eskil Steenberg convinced me of this about a year ago. And I changed my mind on the topic, and I went, actually, no, you're correct. So in C, when you actually look at C, you can actually just like, you can do this with most versions of C. Look at C, right? And then go line by line, statement by statement, effectively, and look at what the naive assembly should look like. And you can just map it 1-to-1, right? You can just do that. There's no like, but defer doesn't allow, it doesn't do that anymore. It actually breaks that model. Defer, you can't just look at it because you're actually copy and pasting and deferring it to the enders of the scope. So now you can't do this trivial, like seeing the naive assembly code just from looking at it. Now, I know that's not how it ever gets executed or lowered down or anything like that. So for people who are pedants in the comments, I know that's not the case. But that point there where Eskil kind of said that, I'm like, oh yeah, you're right, because that actually changes one of the essences of C. So I didn't want defer. Now, I'd still want slices. That's pretty much what I'd want. But from slices, you also get the variodic parameters as well, because in Odin, that is a slice. It's just got some sugar around it, and that's what it is. But that would be like the number one thing I would have, because I'd get bounds checking from it. I'd be able to find out the bugs that cause the bounds checking, because the bounds checking is not the bug, by the way. It's the symptom of another bug. So going out of bounds, I mean, for it. So having that would actually let me find the actual better bugs, if that makes any sense. So that's why if I have to have one.
So slices, but not defer.
Yes. If you only have one, yes.
Doesn't the defer argument fall apart? Like, doesn't that also disqualify for loops? Because, like, I mean, you know that I use the whole crazy defer loop construct. Like, the increment part of a for loop is the copy paste to the bottom of a scope.
You're right. It does get copy paste, but technically it doesn't have to be.
No.
You can still do the block tricks.
Look. No one knows what you're talking about now. You need to introduce the subject, Ryan. It's not like, my loops.
Sorry.
It's like, of course I know.
Your macro thing is, okay, ignore the macro trick that you're doing, right? Yeah? Because that's the macro language. I'm just talking about C. Yeah.
Well, I'm talking about it as well, though, because that macro trick only works because of for loops. Because for loops are doing the copy paste thing, where you can stitch arbitrary comma operators in the increment portion, and they get copied and pasted basically to the bottom of the loop. So it's
but you can still technically write it as if you have. So you got let's say a code block here, another code block here. Like here's the init, the condition, the post, and then the body, and then they could just jump back to it. So you can write it like that. Compilers don't, but you can.
Right. I guess the fact that it's a scope also helps.
Yeah, and the scope helps and all this lot. But yeah, your trick does do the defer thing because it does. Yeah, I'm not explaining what Ryan's defer trick is. It's really dodgy. Is the best way of putting it.
I'll explain it. It's great. I think it's great if you're in C.
Yeah.
It's so the whole concept of the loop thing I'm talking about is basically not a loop. It's a loop with one iteration, but so for people who don't know, I'm assuming most people watching know, but a for loop in C has three portions to it. You've got an initialization portion, a check, a condition for whether the loop should proceed, and then an update portion, which is supposed to happen after every iteration. So basically you've got for int I equals 0, I is less than 100, I plus equals 1, I equals 0, that's the initialization condition, I is less than 100, that's checked every single time you're about to iterate, I plus equals 1 happens at the end of each iteration. The defer loop thing is just saying there's this pattern that comes up a lot inside of all code, basically, where it's like you begin and then end, or you push and then pop, or you start and then stop. Like this constant pattern of like push, code that goes in between the push and pop, and then the pop, right? So all I did with the defer loop is basically, let's just wrap the for loop in a macro, where I've got a macro with two arguments. The first argument is what I want to happen at the beginning. The second argument is what I would like to happen at the end. Now, because of C, these have to be expressions. But because they're expressions, you can go ahead and put the begin part inside of the initialization part of a for loop, and you can put the end part in the update portion of the for loop using the comma operator. So you basically say for int I equals 0, comma, or sorry, it'd be the begin expression, comma 0, so that your int gets 0. And then the update says, I will keep looping until I is not equal to 0. So basically the second I becomes non-zero, this loop terminates. And then for the update portion, you say I plus equals 1, comma, whatever the end part of the macro is. And so basically it does the loop once, but it does the begin part first and then the end part second, but you specified the begin and end together at the top is the only thing it actually gives you. So one example of this that I like, well, profiling scopes is a good example because you can say profile scope, here's the name, scope, and then it's got the begin profiling, end profiling, everything in between is profiled. I use it in UI a lot, so it's like, oh, I want all the text colors in this block to be red, so I'm going to say UI text color, and all that's doing is a push text color and pop text color, and then I fill out all the UI, and everything's got red. So it's dodgy, as Bill would put it, because it's a for loop, right? So if you use break or continue, you're screwed. Like, that's like, you just don't want to do that, really, in this case.
Yeah.
Because it's a loop. That's why I use the word defer loop instead of like defer block or whatever, or like, you know, begin end block or whatever. Because I'm like, I want to remember that this is a for loop. But if you just kind of put that in the back of your head and just don't make that mistake, it actually, it's a pretty nice little meta language kind of thing. but yeah, no, it is a little dodgy though.
Yeah.
A little. How often did you write break or continue and didn't realize what's going on?
I basically never do it, actually. Like, it's not, a lot of people worry about it. In my experience, it's just not, I don't tend to write a lot of code that looks like that, so it's not actually a problem for me. But yeah.
Oh, there is a good comment. Could you define break and continue inside the macro and undef them at the end?
I mean, that kind of that ruins the whole point. Like, because you'd have to, every time you use a defer loop, you have to pound define break or pound define continue. But it's like, the whole point, the whole reason I'm using this macro at all is to be more succinct. It's because I don't want to have a push and a pop and maintain the two pairs of things surrounded, like,
and also
C's
thing doesn't work that way, so you can't define macros within macros as well.
Yeah,
right, that's effectively what you would have to do. It doesn't work that
Well,
way, so like, you can't do a define inside of a define.
My point is it would have to be at the usage site.
So it doesn't work.
Oh, Eskil is in the chat. Listen.
Oh, nice.
Okay.
So beware.
That's fine.
Eskil said, defer is an invisible go-to. A for loop ends with a curly brace, so you know execution goes somewhere else.
Yeah.
This was the talk about what C features you lack. We kind of trailed off a little bit.
Yes.
But we've got the first disagreement between Ryan and Bill.
I have one.
We have a disagreement. Go on. That's right. Go.
Let's go.
I've got one. Well, I think this is actually maybe in the newer standards. But the enum situation is just completely bad.
Oh.
Like, they should just have typed enums, like where you specify the actual base type. And I think this is in the newer standards, but I have not been living with
that's in C23,
yeah. Yeah. See, okay, but I don't want to use C23, so that's...
Yeah, me neither. I still do the same trick where I will have the enum type be actually just a define. Literally, I go type def, we'll say U32 foo, and then my enum is actually enum foo kind, and then that's the, or foo enum, and then it just does that. So in C, when you're doing that, I mean, just to enforce the right size for the enum, because in C, at least the old specs, the size of it's kind of ill-defined. Like, different compilers will say, yes, this is actually int size by default, and then other compilers, they'll go, it's actually the smallest possible integer representation. So it's actually inconsistent. So to make it consistent, you actually have to do this stupid little trick. Now, I know C23 has solved